Welcome to The Explainer. Today, we're going to dive into some pretty cool science hidden inside a simple aerial photograph. We're going to see how what looks like just a flaw can actually unlock a whole new dimension. All right, so let's start with a really basic question. When you look at an aerial photo, are you actually looking at a perfect map? I mean, it seems like it should be, right? A perfect bird's eye view. But, well, the truth is, the way a camera sees things adds a really interesting twist to the story.
And yeah, the answer is a definite no. So on the left, that's the ideal, an orthographic projection. Just think of it like a perfect blueprint. Every single point on the ground is shown as if you're looking at it from directly above. No distortion. But a camera, well, a camera is different. It captures a perspective projection. It sees the whole world from one single point, the lens. And because of that, anything with height starts to look like it's leaning. It creates these distortions.
But here's the thing. This distortion, it's not just some random mistake. It actually has a name, and believe it or not, it's the key that lets us find a hidden third dimension in that flat photo.
It's called relief displacement. And really all that means is that anything with height, a building, a hill, even a tree, it's going to look shifted from where it really is on a map. And the crazy part, the amount it's shifted is directly tied to how tall it is. Okay, so what does this actually look like in a picture? Just imagine a tall skyscraper, and you're looking at a photo taken from right above it. You'd see that the very top of the building seems like it's been pushed farther away from the center of the photo than its base. It creates this effect where the building looks like it's leaning away from the middle of the picture. And here, you can see it perfectly. The bottom of the building, that's right where it should be on a map. But the top, see how it's shifted outwards in the photo? Well, that distance you can see right there on the picture, between the base and the top, that is the relief displacement. Okay, so we've got this predictable leaning thing going on, but this is where it gets really, really clever. This lean isn't random at all. It follows a precise mathematical formula, and that's a formula we can use to our advantage. So, the science behind this, photogrammetry, gives us this surprisingly simple formula. Now, don't worry, I promise we're not going to do a big math lesson here. But we are going to break down what this means, because honestly, it's like the secret code hidden inside the photograph. So let's just quickly run through what's what. D, that's the displacement, the lean we can literally measure with a ruler on the photo. Then there's R, that's just how far the object is from the center of the photo. Again, easy to measure. H is how high the plane was flying, above sea level. And H, well, H is the big mystery we want to solve, the object's real height. And the whole point is that all these things are connected by this formula.
Okay, this right here, this is the light bulb moment. This is where everything flips on its head. That simple camera flaw suddenly becomes an unbelievably powerful tool for science. What we thought was just an error is actually the most valuable piece of information in the whole picture.
So just think about that formula for a second. We can measure D, the displacement, right on the photo. We can measure R, the distance from the center, and we already know H, the plane's altitude. So what's the only thing left that we don't know?
You got it. We can just flip that formula around and solve for H. And what that means is we can now calculate the actual real-world height of anything in the picture, buildings, mountains, you name it, all from a single flat 2D photograph. We've literally just pulled a third dimension out of a flat image.
And that's really the heart of it, that thing that seems like an imperfection. The leaning buildings, that weird distorted look, that's not an error. It's the data. It's the very thing that lets us build 3D maps of the world from the sky. It's a beautiful piece of science when you think about it. All right, so to kind of wrap all this up and make sure it sticks, let's just go over a few simple rules of thumb for how this whole thing works. These are the key takeaways you'll want to remember. And honestly, these rules are pretty straightforward. Rule 1. The taller something is, the more it's going to lean. Makes sense. Rule 2. The farther something is from the middle of the photo, the more it's going to lean. Rule 3. If you fly the plane higher, the leaning effect actually gets smaller for everything. And last but not least, Rule 4. The lean always happens in a perfectly straight line pointing away from the center of the photo. So really, the next time you're flying through a 3D city on Google Earth, or you see one of those amazing 3D maps, just remember where it all came from. You're looking at the super high-tech, modern version of a principle that's been around for a century, a principle that completely changed map-making and intelligence gathering. And it all started with a simple idea, that sometimes the most important information isn't in what's perfect, it's hidden in the flaws.